Hello, and welcome to today's webinar entitled Digital Business Transformation in the Streaming Era. A recorded version of this webinar will be sent to you when the webcast is finished. And now let me introduce today's speakers. We have Jim Kabelis, Lead Analyst for Data Science, Deep Learning, and App Development at Wikibon. We've got Clive Behrman, Director of Product Marketing at Attunity, and Mike Boyarski, Senior Director of Product Marketing at MemSQL. Jim will be talking to us about digital business transformation perspective. Clive will be talking about a path to transformation. And Mike will be talking about database transformation case studies. And now let me turn it over to Jim.
Thank you, Carol. Hello, everybody. Hope you're having a good day. Yes, we're here to talk about the streaming era. In fact, at Wikibon, we're using this term to describe the new era of business where everything is live, always on, and completely continuously streaming. The experiences we have are real-time and interactive and so forth. It's a brand new era. And most digital business transformations that we're seeing out there in the enterprise really involve going entirely low latency from end to end with all business processes. So today what we'll be doing is we'll be discussing this transformation, looking at the role of stream computing in enabling a completely always-on and live and interactive experience. We'll talk about the foundations of stream computing, such capabilities as event processing and continuous processing, in-memory databases, change data capture, and so forth. But first, let's look at the broader business context, really. What it's all about, really, the streaming era, doing digital transformations in the business world. It's all about achieving greater intimacy with the customer. I mean, the customer is now entirely wired or wireless, for this matter, with smartphones, with the Internet of Things in our homes, with Alexa, smart speakers, and whatnot. There's a huge range and a growing range of tools that customers are using to engage with you as a business, and that you as a business can use and are using to find and engage and to retain the customer and to delight them. So if you look at, if we go back to the foundations of modern business management theory and practice, it's always useful to go back to Peter Drucker, of course, the great management guru, late great management guru, who back, it was around the World War II era, so he did a major study of large businesses in the US to look at management practices. And then what he did is he was brilliant about distilling the broader lessons about how to manage a business effectively. And really, he got to the heart of what a business actually is. Why do we have businesses? It's not really to make money. Sure, that's an important thing, but really it's all about the customer. The best businesses, the ones that thrive and innovate, are the ones that focus on the customer. And really, he nailed it when he said the purpose of a business is to create a customer and to keep a customer. And of course, to keep a customer, you have to delight them, give them products and services that meet their needs, innovate, differentiate yourself in a hotly competitive market space, and all of that. So cutting ahead to the 21st century, this is this is still the heart and soul of what business is all about, including digital business. The customer now is increasingly a customer you engage with through digital channels. And so when we look at Drucker's dictum, what we've done at Wikibon is we've broken it out into the various aspects of modern customer to business relationships. And digital businesses are those that create and keep a customer by using digital channels that are continuous. Stream computing is definitely continuous, end-to-end, low latency. Are stateful, meaning that enable you as a business to keep track of the ongoing, evolving state of the engagement across different channels. So there's a memory, as it were, built in to the entire set of channels. So you don't have to, you don't forget where you're at with a given customer. That would be a killer that would mean you lost the customer if you're not on top of the state of that engagement. That are contextual, that you are reaching out and engaging your customer with full context of who they are, where they live, what time it is, or what season it is, and so forth. So looking at the broader context of that engagement is absolutely important to create, keep, and delight a customer. And intelligently, that you're using data, and you're using analytics, you're using predictive analysis, and so forth, to be able to understand who your customer is, where they've come from, what offers they might accept, what they might find satisfying in terms of products and services, what they would be likely to find dissatisfying or irritating, and that you should avoid when you're engaging with them. So in an always-on world, digital business is all about very much using data in real-time environments. So at Wikibon, as we look at the state of modern business and digital business and engagement with your customers, and also engagement with your employees and all of your other stakeholders, it's an era of continual engagement, and continual, always on, increasingly relies on streaming data architectures rather than data at rest architectures. When you look at where big data has come from, it's been very much a data at rest phenomenon until just recently. Databases, big databases in the cloud are very important still, but really where your customer lives is not in big databases. Your customer lives in live or real-time environments. And so more and more of what we're seeing at Wikibon is that more data environments are evolving for enterprises towards what we call all streaming architectures. And there's a variety of streaming platforms that are gaining significant traction and ubiquity in the business world, Kafka and Flink and Spark streaming and so on. I won't bore you with all the details on those, but the important thing is to know that stream computing is coming to every aspect of enterprise, both internal processes as well as B2C engagement channels, to enable customer engagement that is live, interactive, and ubiquitous. Live. Digital businesses catch and keep customers live through their mobile devices, through edge computing, Internet of Things endpoints, through embedded devices. Serverless computing environments are very much live. So first and foremost, the nature of a digital engagement in the all streaming era is that it's live and always on. It's interactive. It's low latency. It's stream computing involves low latency, in-memory, continuous processing, and on-demand architectures that enable a high degree of interactivity between you and your customer at every point in the process. And the data that you're gathering on the customer through that process is being analyzed in real time on your stream computing backbone. So stream computing is increasingly ubiquitous. It's not just ingesting data from sources, it's also processing that data, and it's also driving interactions in the front end with your customers. The era of batch processing and next day the delivery of value are rapidly waning. So it's ubiquitous, and really all processes, internal and external, are moving towards streaming backbones. So customer engagement, as I said, rides on streaming architectures that are in many ways layered. When we say layered, stream computing includes both continuous processing environments, low latency, sub-microsecond, and end-to-end event ingestion and processing. That involves statefulness. It's continuous processing plus persistence and state management. So you're keeping a memory, as it were, within the cloud streaming fabric of the state of your engagement with customers in every transaction, every interaction, and so forth. That enables you to personalize and tune your engagement with customers to moment by moment to specifically what's going on in their world and the world at large. So you don't lose that record of where you're at any point in time. It's contextual. That's stateful, plus it involves the full context, or factors in the full context of where the customer, like I said, geographically is, their social graph, with privacy controls and so forth. and the entire state of the relationship and the context of the relationship you've had with that customer going back and really pointing ahead in terms of the predictive context of what the customer might do and might find acceptable in the future in terms of future interactions with you, and is intelligent. So really, the customer engagement in a layered streaming environment involves a machine learning in stream, embedded in streams to do deep, for example, to do deep learning, to do processing for such things as voice recognition, face recognition, natural language processing, to be able to surface up customer sentiment and whatnot. So natural language processing, quite important. Chatbots, conversational UIs, and so forth are very much a real-time live streaming environment that are becoming critical to almost every application architecture now. In fact, at Wikibon, we've done a number of studies focusing on the new state of the art in terms of building and tuning conversational UI, and streaming backbones are found in pretty much most of these environments. And AI, in all of its manifestations, is quite important. So you're building increasingly edge applications that have embedded AI microservices that are able to do not just natural language processing and predictive analysis, but also able to do a variety of highly advanced analytics that help you personalize your interactions with customers at any point in time. So stream computing is powering digital transformations in business everywhere. In our recent Wikibon Big Data Market Forecast update, what we found from our survey of emerging best practices is that streaming platforms are becoming ubiquitous in many enterprises, in sectors, pretty much all sectors, all vertical markets, and most geographies throughout the world. And in many ways, stream computing is beginning to eclipse big data in terms of data at rest architectures, or supplement them through architectures that are occasionally called lambda architectures. So you have streaming platforms. What we project ahead is that they will become the core focus of most customer engagement solutions for multi-channel, for sales, for marketing, and so forth by 2027, if not sooner. And then what's driving all of this is ubiquitous adoption of mobile devices, first and foremost, smartphones and tablets and whatnot. Embedded devices, the Internet of Things with edge computing, with embedded microservices and serverless computing, are all reliant upon stream computing to do their magic. And so that's driving the demand for these capabilities. And when I say these capabilities, it's event processing, it's continuous processing, it's in-memory databases, it's distributed cache. A fair number of technologies fall under the heading, the Wikibon discussion of stream computing, but they're all focused on low latency interaction and data movement and analytics. Enterprises will continue to grow their investments in streaming solutions while they're attempting to converge those investments with their at-rest environments. So Hadoop, NoSQL databases, RDBMSs are definitely not going away. They play important roles, especially for functions such as providing data lakes for data scientists to use to train AI for a variety of downstream applications, literally downstream applications. So we see a fair amount of Hadoop and NoSQL being used in the whole development pipeline by the developers who build deep learning to handle functions such as face recognition and the like. But really, in many ways, the applications that are being built and deployed into business environments that incorporate AI very much rest on a stream computing backbone to bring in the latest and greatest data with split-second speed into these big repositories, so you can be training your AI models from the latest and greatest data that there is. And then the entire DevOps lifecycle that's pushing these trained AI, deep learning, machine learning models out to applications is itself increasingly a real-time streaming backbone. So that's so stream computing is coming into every aspect of the development lifecycle. So as I've said, streaming is revolutionizing the entire big data ecosystem. So really the data store, as we've known it, increasingly it will be ancient history in the sense that the most fundamental backbone for most business applications will be a streaming environment. Before long, you'll still have stored data. There will be some degree of batch processing ongoing, but that the percentage of data workloads in the enterprise that involve batch movement and batch processing will continue to decline in favor of streaming, low latency, and real-time data movement and processing. Open source projects have come along, and there's been a lot of streaming environments deployed and built out by open source communities. The ones that have achieved the greatest traction so far, both among enterprise customers, but also very much in vendors' solution portfolios, are Apache Kafka, Apache Flink, and Apache Spark Streaming. And we're seeing, at Wikibon, we're seeing a fair number of solution providers also providing abstraction frameworks to help developers to be able to build applications that can tap into any or all of these streaming backbones, depending on the nature of the application they're building or what's deployed into the back end of their enterprise application infrastructure. Stream computing itself, however it's dished out in terms of the underlying code base, is the fundamental trend. So what we're seeing is that all streaming environment might have many different types of streaming backbones handling different applications at different times. But, they're not all interchangeable. So there's a fair amount of statefulness built into Kafka that's not there in, say, Spark Streaming. The point of this webinar is not so much to weigh in on the pros and cons of the different backbones, just to point out that they're all responding to a core set of trends that are driven from the business world. When you look at public cloud providers like AWS and Microsoft Azure, Google Cloud Platform, IBM Cloud, and so forth, they have all put stream computing at the very heart of their capabilities and their future in terms of deploying edge and IoT and serverless applications on streaming backbones. That's very much where the entire cloud is going, and we can see that in these solution providers' roadmaps. And as I've said, the new DevOps workflow is increasingly continuous and real time from end to end, and it rides on a streaming backbone both to ingest the data, to drive the development and training and evaluation of the built-out application assets, and then to drive real-time deployment of code into applications in your business. So streams, not stores, are the transformational platforms driving this new era. So Wikibon, to summarize my my comments, and then to make way for, I believe it's Clive Behrman next from Attunity. Enterprise IT professionals should be modernizing their data infrastructure by moving to a low latency in-memory and stream computing fabric for a growing range of applications, including especially your customer multi-channel engagement and marketing applications. You should standardize on increasing on any of the open source platforms for stream computing, Kafka, Flink, Spark Streaming, and pay attention to the differences and the different levels of maturity and the different levels of industry support for these various stream computing environments, because they're not all the same. Spark Streaming is more geared towards micro batch architectures than, say, Kafka and Flink, which are more true streaming, but every one of these backbones has its own sweet spots, so consider the differences. And then operationalize. Build an intelligent streaming backbone that is, of course, robust and scalable, stateful and continuous, and make sure that you standardize on a streaming backbone that enables you to build and deploy advanced analytics, machine learning, deep learning, AI in stream to process the huge gusher of data coming from all over, especially increasingly machine data from the Internet of Things and smartphone endpoints and the like. So that said, I'm going to hand it over to Clive, and they'll discuss modern data integration in the streaming era.
Thanks, Jim. And so I'm going to start my pitch sort of where you left off, Jim. You know, you're on about modernizing, standardizing, and operationalizing your environment, moving from kind of like where we are to kind of where we want to be, and how do we innovate. Now, you know, as you could probably tell from my accent, I'm not from the northeast of the United States where I am right now, but I've been here for a while. And, you know, Maine is sort of has this saying, you can't get there from here, right? We want to modernize, we want to operationalize, we want to standardize, but how do we do it? I mean, you know, if you consider most architectures and most implementations that we have today, this is the state of play, why you can't get there from here, or why we think we can't. You know, most of our data that we have in our organization, we've been traditionally used to using things like data warehousing for analytics. You know, we are using batch to get that data in and out. Jim mentioned data at rest. You know, it's resting in the data warehouse. We get it in and out with batch, and it's mostly on premise. And all of the sort of trends that were mentioned in the Wikibon report, it's kind of like, you know, for data warehousing, we're sort of moving towards more data lakes, and they can be in the cloud and on-prem. As we talked today, the mode is not really batch, it's streaming, because we want to take action on the data and on the changes as they occur. And you know, we don't want to invest more time and more money doing the same thing that we did before with all of our data on-prem. We can pay as you go, on demand, moving it to the cloud and getting all of that flexibility. And as James rightly stated, it's a mixed mode, right? We're using not just data warehouses and batch and on-prem today and data lake streaming and in the cloud. We've got a massive amount of different options, and in many cases, different technologies for very similar use cases. You know, we might be using a new application, and we're going to modernize, and we'll see the beauty of MemSQL shortly. We're seeing how we're using maybe Kafka for streaming, or maybe Confluent or something like that as a paid product. Maybe we're using Hortonworks and Cloudera in many instances, and Google and Amazon and Azure all at the same time. So very much a mixed mode, but again, the takeaway is when the mode that we're moving to, and the mode that is most important, is streaming, because we can leverage things as they happen and when they happen, as opposed to that kind of batch delay and make a correction. So getting to there from here, right? I mean, ideally, we want to take it and leverage the key to this technology is CDC, which is change data capture. Now, the nice thing about change data capture is that the whole idea, as you see in a second, my existing applications, if you like, will still write and still perform their actions on the database. Hopefully you can see my database or my data warehouse or my files. In this instance, my database is flashing here. As I use the application, it writes the not only to the database, but writes the action to the database log. We can look at the database log. The transfer of the data can occur because we just see essentially the changes, the incremental changes. So as I use my application, I make an update to the database. The system writes to the log, and then we magically pass that incremental change to streaming. Now, you could write all this by hand using the CDC kind of pattern, but you know, why bother really? Because you know, we have the technology. I sound like Steve Austin, the $6 Million Man, if you can remember back that far. Right? Attunity has this product called Attunity Replicate that sits in the middle of our source on our left and our targets on our right, and can actually change those incremental updates and take those changes that occur in real time and translate and transform them into essentially streaming events that can then be picked up by other databases, or by, as James mentioned, by Kafka or other streaming technologies. And then, you can pass those further on down the line for further processing, which we're going to see from our MemSQL folks. The nice thing about Attunity Replicate is that it actually takes care of a whole bunch of work for you, right? The translation from database data updates and turning it into streams. It will automate the entire process. So that's things like it creates the schemas on the targets. We can change map any databases or any data fields from source to target. There's that moving from that batch kind of mode to essentially change updates as and when they happen. So you're moving from batch to essentially a change data capture transition, or if there's any any amendments or changes that happen to the applications on the source side. So maybe you get a database schema update. Attunity Replicate will propagate that change, not just of the data itself, but of the metadata and the changes to the source tables into the target. We can do some other things, like some light filtering, so I don't need to, if I'm only interested in, I don't know, updates from a particular set of tables in my source application, I can do that. And then there's some light transformation too, if I want to apply some rules on the data and on the changelog as the transaction and as the transfer occurs, I can do that too. Now, the other nice thing, as my little animation will show you here, there's absolutely no coding, right? So I'm dragging, as you see in the diagram here, and dropping my source to my target. I can pretty much connect any sort of data source to any data target. You see, I'm picking Kafka as my target here. So there's no hand coding. We're trying to get all of rid of that hand coding nonsense. We can do it visually. The transfer of the data as it goes from source to target now in a stream is extremely fast, whether it's on-premise or between an on-premise or a cloud application or cloud data target. As we said, automatic replication, so we can operate in a number of modes. Perhaps I want to, when I first stand up MemSQL, perhaps I want to first load it with data from an existing system, so you can do an update, a massive update all at once. And the other nice thing of Attunity Replicate is there's agentless configuration. Now, what does that mean? Well, traditionally, we've seen in other technologies, you have to have some sort of agent that you load on your database or on your source system, whether it be on your Hadoop cluster or something like that on the source. We don't need to do any of that. As we said, there's the Attunity Replicate server that stands between the source and the target, and it takes care of all the communication and all the data transfer for you. So very, very quick, very productive, and superbly fast to get that translation from what is traditionally, I hesitant to say a legacy technology. Databases have been around for a while, but from those sort of legacy technologies, like whether it's an SAP or an Oracle or a traditional database application, whether it's mainframes, even maybe a flat file transfer, right? We can translate those updates into essentially streams. And plug into streams like, as we show there, Kafka. Differentiators there when it comes to streaming. Again, we said no impact on the sort of host system, right? There's no impact on the database. There's no extra load. The data transfer happens in real time. We can manage pretty much any endpoint and stream at scale, and the stream is optimized, right, as we already talked about. So the roadmap really is clear, right? We can take Jim's modernize, standardize, and operationalize. We can modernize, think hybrid, not just between different technologies, but we're thinking cloud and on-prem. Jim mentioned choosing best of breed components. I don't want to give the idea that you know, you're going to throw everything that you've had out of the window. You can add Attunity to an existing stack. Embrace streaming, as we said, to give you that modernized, modern data flavor. And again, standardizing. Add CDC to your stack, right? Align the skills that you have and maybe close those gaps as it relates to how you want to implement and move that data, and operationalize, right? The more you can automate things with like Attunity Replicate to automate the data transfer and to automate all the source and target updates, you know, you're going to reduce the cost it is to manage and roll out those solutions. Once you've got your sort of data pipelines in place, you know, keep leveraging those reusable data pipelines. That's where you're going to get your productivity. And, you know, we can then build repeatable processes, especially as it relates to loading the data and getting those continual database updates that were you know, existing technologies and older legacy technologies, and now you've transformed them and turned them into real-time streaming. So I didn't really mention who Attunity is. You know, we're the leading provider of data platforms and real-time streaming to data lakes, streaming and cloud architectures, the #1 provider of change data capture, the #1 cloud database migration technology provider. So we are embedded into several cloud technologies, and we've already moved over 70,000 databases. The Attunity technology has moved over 70,000 databases from on-premise systems to platforms like Amazon Web Services, and we're the #1 in ease of use. So as you saw with the little animated screenshot there, right? It's designed to accelerate the deployments and rollout of streaming architectures. As proof, you know, we've got thousands of customers, and a partner of choice for many, right? You can't really be a data sort of integration vendor or a CDC vendor without having those strong ties to those traditional platforms that you may have in your current environment, and strong ties to new and upcoming technologies that you may look to build out brand new systems too. So again, partner of choice for folks like Microsoft, Amazon, Oracle, IBM, SAP, and global SIs too. Now, Attunity Replicate itself is just one core part of the Attunity sort of data platform. There's Attunity Replicate to help you automate that universal real-time data delivery and updates. We've got Attunity Compose, which is essentially a data warehouse or cloud data lake automation that will help you accelerate and create those not only those analytics ready sort of data structures, but those analytics ready or those pipelines to help you make your data analytics ready. And Attunity Enterprise Manager will help you control all of those things together on a massively enterprise scale. And with that, I'm going to hand it off to MemSQL. Over to you, Mike.
Fantastic. Thank you, Clive and Jim, for the setup. So I'm Mike Boyarsky. I head up product marketing here at MemSQL. I'm going to spend a little bit of time talking about real customer case studies who've gone through essentially a real-time or transformational improvement of their database platform. So for those that are new to MemSQL, if you've not heard of the company, just a little context, and then we'll get into some of these examples. So we are focused at MemSQL about enabling any company, any size organization to become real-time. And real-time is a spectrum. Some organizations want to get to more intraday analysis. Some organizations want to get to intra-minute. And others want to simply just perform more faster in terms of processing and acting on their data. We are a top-ranked database and data warehouse in one. So this is something that Gartner has provided some great research on the capabilities of MemSQL. And you can see by some of the customers that we appeal to large established organizations as well as digital native organizations like Uber and Pandora, companies that have built their foundation on technology. So on the next slide, I will talk a little bit about why people select MemSQL. And it has a lot to do with some of the challenges around delivering continuous analytics or continuous processing of data. And it hinges on some of the database limitations that are out there today. One is that the loading of data for most database platforms can be challenging. There's a lot of locking mechanisms and batch processes that are part of that. So we see a lot of customers challenged with being able to ingest and store that data as it is created. Another challenge that we see a lot of customers facing is lengthy queries or query processing. So this is the spinning dial of your dashboard tool of choice, or simply waiting for that scan to complete before that insight is delivered to the screen. And the third and final is concurrency. We know for a fact that many organizations are trying to deliver data and analytics to more people in the organization, or even going further and providing analytics to their end customer. So we're moving from tens of users to thousands to tens of thousands of users needing access to data. And these are three sort of challenges for database platforms of today. Here's what MemSQL can deliver to these challenges. The first is live loading. Continuously loading into a relational SQL-based environment on an ongoing basis allows a tremendous amount of value for responding and acting in real time or on demand. We can do this because we can stream ingest data. We have full update capability in our platform, so we're just like any other traditional relational database. However, we can work under stream processing conditions. We can ingest data from a variety of sources, so there's no limitations in terms of what types of data we can take and collect. And then once the data is landed in the system, what we do and what we're best in class at is delivering ultimate performance for your queries. And so we have a number of innovative techniques that I'll speak to in just a moment around delivering fast analytics across billions or even trillions of rows of data. We just recently published a benchmark around processing 1 trillion rows of data per second. And so that's something that we feel delivers just best-in-class performance, even regardless of size of your data set. And then lastly, the scalable user access. We can deliver analytics with high performance and guarantee or predictable performance because we're a distributed architecture. We were built with modern web scale principles, which means we take advantage of commodity hardware, we distribute the load, and we take advantage of memory so that we can deliver ultimately the best performance for your application. A little bit about our architecture so folks can kind of understand how we can deliver this. So again, we're able to deliver operational workloads, that's transaction processing, your classic OLTP workloads, as well as analytic workloads, which is the classic OLAP style, which is column store, configuration of data, very fast analytic processing, all in one unified system. So stream ingestion is something that's very natural to the platform because we optimize using memory-based compute. And then we also take advantage of disk for analytic and column store oriented analytics. So this is the unique combination of a modern data platform. It's taking advantage of a streaming architecture, but also leveraging some of the traditional disk-based approaches, but using modern techniques to accelerate the processing. So this is what the future is. It's today. It's here with MemSQL, and so we'll talk about how customers are using this architecture with some examples. The first is Kellogg. So Kellogg was struggling with delivering more continuous analytics on a fulfillment and customer logistics process. And so the challenge that they were faced with was a classic sort of batch process that included moving data from an SAP application environment, taking advantage of their SAP data services technology. And this environment was simply from end to end, from the point of data landing in the SAP system to data being available for analysis, was taking, in some cases, days, to other cases, maybe a week, based on unexpected failures and the way the process was set up. And so if you look at some of the sort of inspecting some of the challenges with this process, 24-hour ETL process is still a very common technique that you can use to mitigate sort of impact to that operational system. In some cases, the data load or payload is so large that you have to batch it up and load it into your resident data warehouse for analysis. And there's also a lot of single-threaded processes out there using these sort of traditional technologies. And the other thing is that when they landed the data into their data, in this case, their data mart, using MySQL technologies, the queries that they were running against this database was taking a very long time. And so they were seeing a lot of concurrency issues and a lot of customers that were just not getting the insights they needed in a timely fashion. So with MemSQL in place, they eliminated their ETL batch process, and that they were able to achieve this because they could get to more continuous updates. So they're essentially taking advantage of the same data integration technologies through SAP, but they were taking advantage of more parallel processing. And that parallel processing can work because we are a distributed database. So the customer could load data continuously into MemSQL as it was being generated within the SAP environment. And they essentially eliminated 22 hours down to 43 minutes in terms of loading into MemSQL. What else? The other benefit that they achieved with this environment was the Tableau experience accelerated by about 80x. And so this was based on just classic query processing improvements using today's advanced techniques. So here's the net of their results. It was faster data loading, moving from 22 hours to 43 minutes into a data warehouse environment, which is what MemSQL served as, and then ultimately 80x query performance improvement. So the end-to-end cycle from their analytic process went from a weekly process down to intraday or daily. And the result of that was making more frequent decisions that resulted in saving money, delivering a better experience to their customers, and ensuring that their inventory management process was optimized. So that was a great success story for Kellogg. On the next case study, I'm going to talk a little bit about how a U.S. oil and gas company had a particular challenge managing and processing invoices. So the frequency and the accuracy of their invoicing analysis was essentially impacted by the limits that they could do on their operational application. And this is a very common challenge that many organizations have, which is delivering essentially a continuous process on a living sort of live operational system. And so what they were using was Oracle Financials. Oracle Financials was essentially processing these invoices. Under certain circumstances, these invoices would become duplicated, and there was either user entry error or automated systems upstream to the application that were creating duplicate records. And unfortunately, what would happen with this process is the system would actually bill or send invoicing to their customers and partners incorrectly. And the processing of those incorrect invoices resulted in expensive clawbacks, expensive rerouting of expenses to different organizations. The net result was more cost. And so they wanted to be able to do more intra-analysis or speed up the analysis that was happening on that financial system so they could avoid these costly overruns. So when they went to MemSQL, they were looking at eliminating their batch job process, which was taking about 12 hours to run on Oracle. And many of those processes were erroring out. So you could wait 9 to 10 hours before recognizing there was an error. They would have to rerun that job and they would lose a day. And meanwhile, that invoice process was moving forward. They tried to tune Oracle to run this process more efficiently, and they simply couldn't get the performance from that environment. And so also the end result, again, was the fact that they had a lot of incorrect data getting proliferated through their system, and it was causing additional costs in their operations. So on the next slide here, when they introduced MemSQL, they were able to eliminate, taking advantage of a change data capture process where every transaction that occurred on that Oracle system was replicated to MemSQL in real time. And then they would run that, that rules engine process on MemSQL eventually as each event occurred in the database. And that result was highly accurate data living in MemSQL. They could clean the data in MemSQL. It actually changed the source system, the source record system, so that they got the best, most accurate results. And this was essentially a living, breathing system that delivered highly accurate results and lowered the sort of error rate in their invoice processing system. And all of this was done with minimal disruption to their operational system. So here's why customers want to use MemSQL with Attunity. You can take advantage of live synchronization of your operational systems without impacting the performance of those applications. Once you land the data into MemSQL, now you have a high-performance, modern database platform that can give you intraday analytics, high-speed sort of performance to your dashboards, much greater concurrency of your end users in terms of delivering data and insights throughout your enterprise. And then you have the flexibility to deploy this environment anywhere. We are a product that can run on premises or the cloud, and this gives you sort of the flexibility to deploy and leverage your data anywhere you need. So the end result of this platform is essentially moving to a more modern streaming-based architecture using the familiarity of SQL, a relational database that can scale to your needs. And so with that, I'll hand it back over to Carol to wrap up and offer any sort of questions that we might have.
Sure. Thanks, Mike. I want to tell people for next steps, we have the research paper from Wikibon, Big Data Analytics Trends Forecast, that people can download using the link here. For Attunity, we have a free ebook on streaming change data capture. And also, MemSQL's got a book as well about real-time data pipelines that you can download for free using the link on this slide. Thank you, everyone, for your time today. We appreciate it.